Hello everyone, today shall discuss about algebraic expressions, that is chapter 12. Here you see, today we have an introduction of algebraic expressions. We have already come across simple algebraic expressions like x plus 3, y minus 5 for x plus 5, 10y is equal to 5 and so on. In class 6, we have seen how these expressions are useful in formulating puzzles and problems. We have also seen examples of several expressions in the chapter on simple equations. Expressions are a central concept in algebra. This chapter is devoted to algebraic expressions. When you have studied this chapter, you will know how algebraic expressions are formed, how they can be combined, how we can find their values, and how they can be used. How are expressions formed? We know very well what a variable is. We use letters x, y, l, m, etc. to denote variables. A variable can take various values. Its value is not fixed. On the other hand, a constant has a fixed value. Examples of constants are 4, 100, minus 17, etc. We combine variables and constants to make algebraic expressions. For this, we use the operations of addition, subtraction, multiplication, and division. We have already come across expressions like 4x plus 5, 10y minus 20. The expressions 4x plus 5 is obtained from the variable x, first by multiplying x by the constant 4 and then adding the constant 5 to the product. Similarly, 10y minus 20 is obtained by first multiplying y by 10 and then subtracting 20 from the product. The above expressions were obtained by combining variables with constants. We can also obtain expressions by combining variables with themselves or with other variables. Look at how the following expressions are obtained. X square, 2y square, 3x square minus 5, xy, 4xy plus 7. The expression x square is obtained by multiplying the variable x by itself, that is x into x is x square. Just 4 into 4 is 4 square. We write x into x is x square. It is commonly read as x squared. Later, when you study the chapter exponents and powers, you will realize that x square may also be read as x raised to the power 2. In the same manner, we can write x to the power cube, x into x, that is x to the power cube. Commonly, x to the power cube is read as x cubed. Later, you will realize that x cube may also be read as x raised to the power 3. X square, x cube are all algebraic expressions obtained from x. The expression 2y square is obtained from y. 2y square is equal to 2 into y into y. Here by multiplying y with y, we obtain y square and then we multiply y square by the constant 2. In 3x square minus 5, we first obtain x square, then multiply it by 3 to get 3x square. From 3x square, we subtract 5 to finally arrive at 3x square minus 5. In xy, we multiply the variable x with another variable y, thus x into y is equal to xy. In 4xy plus 7, we first obtain xy, multiply it by 4 to get 4xy and add 7 to 4xy to get the expression. Terms of an expression. We shall now put in a systematic form what we have learned above how expressions are formed. For this purpose, we need to understand what terms of an expression and what their factors are. Consider the expression 4x plus 5. In forming this expression, we first formed 4x separately as a product of 4 and x and then added 5 to it. Similarly, consider the expression 3x square plus 7y. Here, we first formed 3x square separately as a product of 3 and x. We then formed 7y separately as a product of 7 and y. Having formed 3x square and 7y separately, we added them to get the expression. You will find that expressions we deal with can always be seen this way. They have parts which are formed separately and then added. Such parts of an expression which are formed separately first and then added are known as terms. Look at the expression 4x cubed minus 3xy. We say that it has two terms 4x square and minus 3xy. The term 4x square is the product of 4x and x. And the term minus 3x square is the product of minus 3x and y. Terms are added to form expressions. Just as the term 4x and 5 are added to form the expression 4x plus 5, the term x square and minus 3xy are added to give the expression 4x square minus 3xy. This is because 4x square plus minus 3xy is equal to 4x square minus 3xy. Note that the minus sign is included in the term. In the expression 4x cubed minus 3xy are, we take the term as minus 3xy and not as 3xy. Minus is minus 3xy. That is why we do not need to say that the terms are added or subtracted to form expression. Just added is enough. Factors of a term. Here you see, we saw above that the expression 4x square minus 3xy consists of two terms 4x square and minus 3xy. The term 4x square is a product of 4x and x, and we say that 4xx are factors of the term 4x square. A term is a product of its factors. A term is a product of its factors. The term minus 3xy is a product of the factors minus 3x and y. We can represent the terms and factors of the terms of an expression conveniently and elegantly by a tree diagram. The tree for the expression 4x square minus 3xy is shown in the adjacent figure. Here you see 4x square minus 3y, 4x square. It is 4x square. 4x square can be written as 4 into x into x. And minus 3xy can be minus 3 into x into y. Here the expression 5xy plus 10. 5xy, that is 5x and y. And 10. This is 10, and it will be added to get the expression. Now we'll deal about coefficients. We have learned how to write a term as a product of factors. One of these factors may be numerical and other algebraic, that is, they contain variables. The numerical factor is said to be the numerical coefficient or simply the coefficient of the term. It is also said to be the coefficient of the rest of the term, which is obviously the product of algebraic factors of the term. Thus, 5xy, 5 is the coefficient of the term. It is also the coefficient of xy. In the term 10xyz, 10 is the coefficient of xyz. In the term minus 7x square y square, minus 7 is the coefficient of x square y square. When the coefficient of a term is plus 1, it is usually omitted. For example, 1x is written as x square. 1 x square y square is written as x square y square, and so on. Also, the coefficient of minus 1 is indicated only by the minus sign. That is minus 1 into x, that is minus x. Or minus 1 into x square y square is written as minus x square y square, and so on. Sometimes the word coefficient is used in a more general way. Thus we say that in the term 5xy, 5 is the coefficient of xy, x is the coefficient of 5y, and y is the coefficient of 5x. In 10xy square, 10 is the coefficient of xy square, x is the coefficient of 10y square, and y square is the coefficient of 10x. Thus, in this more general way, a coefficient may be either a numerical factor or an algebraic factor or a product of two or more factors. It is said to be the coefficient of the product of the remaining factors. Right here you can find here the different expressions and terms and also the numerical coefficient. Xy plus 4, term which is not a constant, the xy. Numerical coefficient is 1. Here 13 minus y square, term which is not a constant, that is minus y square, and numerical coefficient is minus 1. Here 13 minus y plus 5y square, the term which is not a constant, that is minus y and plus 5y square. And for numerical coefficient, this is for minus 1 and this is for 5. 4p square cube minus 3p q square plus 5. 4p square cube is a term which is not constant, and minus 3p q square is not a constant. Numerical coefficient, this is numerical coefficient of this is 4, and numerical coefficient of this one is minus 3. In this way, you can find the various coefficients. In this example, you also say here 4x minus 3, that is term with factor x, 4x, and coefficient of x is 4. Term with factor x is minus x, and coefficient is minus 1. Y square x minus y, that is y square x, coefficient of x is y square. 2z minus 5xz, minus 5xz, coefficient of x is minus 5z. The method is similar to that in above. Here is 4x, the same way. A term with factor y, that is minus 3y, coefficient is minus 3. Yz, coefficient of y is z. Yz square, coefficient of z is coefficient of y is z square. And my, coefficient of y is m. Like and unlike terms. When terms have same algebraic factors, they are called like terms. When terms have different algebraic factors, they are unlike terms. For example, in the expression 2xy minus 3x plus 5xy minus 4, Look the terms 2xy and 5xy. The factors 2xy, that is, are 2x and y. The factors of 5xy are 5x and y. Thus their algebraic, that is those which contain variables, factors are the same, and hence they are like terms. On the other hand, the terms 2xy and minus 3x have different algebraic factors. They are unlike terms. Similarly, the terms 2xy and 4 are unlike terms. Also terms minus 3x and 4 are unlike terms. Now we'll find about what is about monomial, binomial, trinomials, and polynomials. An expression with only one term is called a monomial, that is 7xy minus 5m, 3z square, 4, etc. An expression which contains two unlike terms is called a binomial. For example, x plus y, m minus 5, mn plus 4m, a square minus b square are binomials. The expression 10pq is not a binomial, it is a monomial. The expression a plus 5, b plus 5 is not a binomial, it contains three terms. An expression which contains three terms is called a trinomial. For example, the expression x plus y plus 7, ab plus a plus b, 3x square minus 5x plus 2, m plus 10 are trinomials. The expression ab plus a plus b plus 5 is however not a trinomial, it contains 4 terms and not 3. The expression 5x plus y plus 5x is not a trinomial as the terms x and 5x are like terms. In general, expression with one or more terms is called a polynomial. Thus, a monomial, binomial, and trinomial are all polynomial. State reasons which of the following pairs of terms are like terms and which are unlike terms. Here you see that is 7x and 12y. The variables in the terms are different. Here these are 5x. The algebraic factors same or different. Algebraic factors is same. Like unlike term, this is like terms. Both are x, that is like terms. AB and ABA, that is also like terms. Remember AB equal to BA, right? In this you can find the different for whether it is different or not. Here the term 3xy and xy, it is different. 6xy square, 9x square y, it is different and unlike terms. Pq square or qp square, these are like terms, same, that is like, not numerical factor 1 is not shown, right? Following simple steps will help you to decide whether the given terms are like or unlike terms. Ignore the numerical coefficients. Concentrate on the algebraic part of the terms, right? Algebraic part. Check the variables in the terms. They must be same. Next, check the powers of each variable in the terms. They must be same. Note that in deciding like terms, two things do not matter. That is the numerical coefficient of the term, and number 2, the order in which the variables are multiplied in the term, right? In this way you can find whether they are like or unlike terms. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.